Can we start or we can wait for some others? Yeah, okay, thank you. Just I'm sharing. Okay, so this was what I'm saying that okay, so this load side have given the priority. So based on that, we are particularly controlling this power in case of electricity. For that, we made a two types of flow chart. One is whether to give the priority to the renewable energy, and then if a surplus will be generated, then it will be fed to the grid if the generated electricity through renewable energy is fulfilling the load, then no need of the supplying the electricity to the grid. Uh, then particularly grid said particularly circuit breaker will be in a kind of so that it will not going to supply the electricity only make the connections. And then battery which was a we can say the it will be giving a supply to the control circuit of a processor. Another we have that diesel generator in the back. So if all fails, okay, all is not there, then diesel generator will become the picture and it will be give the electricity to the so this is the first thing. Another we consider renewable energy, then battery, then grid, and then diesel generator. So likewise there will be two kind of operation in case of the this electricity. So here we have a few questions for the modeling purpose and kind of heuristic, using a heuristic optimization techniques where we can able to calculate the how the power flow from the different circuits and how then control a controller acting particularly will be possible. So these three, and at the end what we can able to calculate the balance particularly power at the um, grid side will be equal to the power consumed minus this particularly power generated by a renewable. Pi is nothing but the power generated. So before moving to the MATLAB, which is the latest MATLAB version presently in their in the system. Anyone? I think मैडम इज देयर. मैडम मैडम कौन सा है लेटेस्ट? अदर लोगों ने ज्वाइन किया है क्या सर? ओके, so which is the yes, which is the latest MATLAB version so that I can yes, what madam said? Huh? Do not know. Okay. So that R 2024B, which was which have major updates, which is like a 5G toolbox was there, which explores 6G waveform generation using the wireless waveform analyzer app to perform a single quality assessment of acquired 5G waveform. Another is because controller system what was going to be used in the case of the automation. So in that case, that toolbox is also interactive DSP, digital signal processing, IP designer app to customize algorithms and generate the codes for communicating with the uh, while interfacing. And that there will be some verification components also that in a simulation that simulating control design and implement non-linear and data-driven control techniques such as sliding mode and iterative learning control. And the fourth one was the system composer, which was subsetted views, which describes system behavior with activity and sequence diagram. So this was the latest. So I'll add one of the MATLAB simulation. What I'll take now for the this. Yeah, sorry. Okay, now it's visible very clearly, na sir? Yes, yes, yes. Or in now this one we did it for a 240 volt. See, there is one word transformer less means what? Because in a domestic consumer sector, okay, so they have the 230. That means what, approximately if I want to calculate, it's coming to 56 volt. Okay, so that's why we are taking it's a 240 VRMS file design. So in that case, no need of a transformer because our solar system, whatever the inverter we are using, see this is an inverter over here. Uh, Through EH breeze and to the list, and then grid come the picture. So this is my loads, which are loads are going to be satisfying by the system. So what we did is directly integrate. So what care we have taken for that is we have a, particularly PU model in our example that of a 14 Trina solar, which was model available in MATLAB. And at normal temperature, generally with 25 degrees Celsius, solar irradiance we given 1000 watt per meter square to produce that voltage by this PV system. Okay, this PV array by a 3500 watt. So there are two small capacitor connected in a PV array that will be boost the voltage building capacity. So there is a single phase DC to AC converter. We are going to say it is a inverter. So which will be a PWM controlled single phase fully bridge IGBT module, whose topology and grid filter is classified based on the filters configuration in case of a particularly electrical equally between the line and the neutral branches. So when we did in inverter control, what we see is there are four parameters. That is the MPPT controller, voltage, VDC regulator, then current regulator, then power line communications for measurement of the parameter, and another is a pulse width generator, which will generate the signals for controlling the electrical uh, signals. And then while the load and utility grid, the grid is model using a typically pole mounted, where it is going to supply the electricity of the 11 kV. So RMS voltage 14 on the primary side. Okay, it's a 14.4 K. So and the secondary of a 240 volt with the center tap transformer. So these parameters we are considered for the design. Is it? So it's a simple for domestic. This we can give to the uh, on the second year level to the student. Is it not? सर हम दे सकते हैं ना सेकंड ईयर के लिए बच्चों के लिए ये करो बेसिकली दिस वी कैन डेवलप वी कैन सिमुलेट इट वेरी वेल एंड we can ask them to try to manufacture or try to particularly develop a circuit for that. Yes, sir. Gosavi, sir. Yes, 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 yes. So that's why I given this the faculty which are there, they can give this to the student. Another we have I have particularly model that is a 100 kilowatt grid connected PV array where with utility as well as so where in this particularly three phase three level voltage sources are to be used. So here on this side, these blocks are available. The faculties, okay, so already you are familiar with this MATLAB, so I'm not going to go in more detail. So these PV pulses, this PV array model was available. This will be give the output. So for controlling this all, this we have uh, particularly this boxes was there, and then bridge level, particularly inverter was here. This is load here from the grid side. Okay, this was a, we can say, point of common coupling where we can integrate the electricity. So even here, I want to say that when this we did for a student at that time only this parameter is important, which is a 5 kilohertz DC to DC boost converter, which increasing voltage from PV natural voltage, which is upper to 73 volt at the maximum output. That will be to a 500 volt DC. Duty cycle and all that we need to set according to the particularly power electronics device. Is it? Here, there's some specification for one module. Okay, we what calculations. So number of series connected cells are 96, which have open circuit voltage of 64.2 volt, short circuit current of 5.90. So these we need to set in a simulation. Okay, and then we can able to calculate the other parameters which we can say in case of the um, solar photovoltaic output or solar PV output. And accordingly we can design the inverter, and from that we can calculate the what will be the current capacity to be delivered, and then what type of power, instead of saying power electronics device, what type of, okay, we can see the capacity of that power electronics devices. So also you can, it is possible to run this simulation at for a 0 to uh, 0.5 second. You can run at a 0.6 second, 0.6 second, 1.2 second. And what we are observing in that case is that की बघून घ्या म्हणजे तुम्ही जरा सगळे की मी when I run it from the t to 0.2 second to t to 0.05 second, so this scope which was there 220 320 volt, and that time when it is a 0.0, this is 500 volt. हे बघा हा इकडं. Then again here it is basically um, for that 1.2 second. Okay, so the particularly duty cycle we have to set. Otherwise, the output will we are not going to get accordingly. This we did it for a 250 kilowatt grid connect. This you can give to the some higher level, third year student, final year students as a project. Okay, so that they can understood that concept very means that they can do it very well, and they can do hardware model, and here they can it's possible to particularly make a paper on that. So what for making a paper we required, I'm going to say is on the on a research point of view, what we required is what we are thinking. This one means a block functional block diagram. Then we have to make an algorithm for that, and we have to write modeling equations for it. Then we need to go for a simulation. Is it? Then once we fix the capacity of the simulation, it would be possible to particularly. So likewise that I have given another example of a 250 kilowatt where design parameters. Another that on-grid solar system which was of some we can say 2400 watt. Okay, so that can each model means that if six models are there, so this will be each of a 400 watt, 1 2 3 4 5 6. So that will be also, it means that strings we can use by using a partial shading on the based on the direction, whether north to south. Okay, will decide the output. Okay. Then 400 particularly kilowatt grid connected wind farms. This also will be. Why I'm telling that कि ये सब एग्जाम्पल मैं क्यों बता रहा हूँ आपको कि government is taking initiative to on the solar rooftop. Even they are giving to the particularly uh, mm, irrigation purpose. Okay, so where this pump water circulating pump system so is there. So in that case, three phase if supply is there. Okay, so then they can make student can make their own project hardware setup, and they can take that work so in the form of research. So this what is my initiative to. These are some references for getting. So this is what for my presentation. Hello. Uh, Visible stop. Okay. Where is my letter? Huh? No, yeah, that's I did. Hello, Mane madam. Good afternoon. Mostly madam, good afternoon.
Good afternoon, sir.
I think that was no. This is what 5 to 6 models. What I did in a MATLAB, and on that I did a three research paper. One of them is in a Scopus journal. So likewise, that you can actively involve the student. Okay, so don't involve only the things from the books. Okay, so you can give the some tasks. That is what the NEP says. Okay, so new education policies. I have some
Yes, sir.
PPT. Yes, yes. Anyone want to say anything? Yes, its forum is open because I'll take another 15 minutes for energy storage. Yes, ma'am. Santosh sir, is it okay?
Yes, sir.
Okay, so uh, this what my intention was that how we can implement the research and innovation in the student. Okay, so instead of mugging the things from the book, writing the answers and getting the marks. Okay, so that we need to change in a student mind. Then it will be only possible that we can motivate the students for the research, as well as we can try to develop some labs in our own institution. That was my basic intention over here. So I was there with Shivaji University for 3 years in one of the renowned uh, college, that Kolhapur Institute of Technology, KIT. So during introduction, that madam told it, but what was is today's scenario is concerned that we need if you want to survival in the market, then we have if we want to prove ourselves, our college is a good engineering college. So teachers' role is a prime role in a really for any institution. So that is my perception, my views. बरोबर आहे ना सगळेजण?
Yes, sir. Correct,
Yes,
correct.
sir. Yes, sir.
Okay. So then electricity is one of the wide area where student can get the good opportunities. Okay. But there was a thing that how that artificial intelligence will become AI is coming in the market, and then it is grabbing the market. So we need to add that in our electrical engineering. Okay, so that was what is we need to think, and that's why autonomy is given to the by the autonomous institutions have a syllabus revision. They can do it in their syllabus as per the recent trends in the market. Not only that, university he used to take that syllabus for 5 years, 6 years, and same we are means that मी ग्रॅज्युएट झाले तरी पण आता तेच सिलेबस मध्ये आहे. तर मुलांना आपण वेगळं काही शिकवतो काहीच नाही. Okay, so that is my what own perception or own thinking about that any kind of particularly teaching learning process. Okay, so have a 5 minutes break. तर break घेऊया की maybe means I will take a water. Okay, चालेल, पाणी पिऊ का सर? हां हां. So, is my screen is visible to all of you? Okay, so I'm just only going to take a overview because the energy storage uh, for electrical grid applications. This was because again energy store here in an energy store we can talk a lot on that, and then it's also possible to make innovation invention in this field also. So when we talk about the electrical energy storage, okay, it's again in the form of conversion of energy. So there are some mechanical energy storage system, electrochemical energy storage system, chemical energy storage system. Already we discussed. Means what there is it is there in a use chemical energy storage system. Then electrical energy storage system, thermal energy storage system. Then what are the some applications of the energy system in the uh, power grid that particularly energy how we can arbitrage then we can how give the capacity credit then the next trend is going to come in the market is ancillary services and most important then when we need to attract the customers for that some on the customer side benefits and this will be going to happen when some optimization formulations for the battery dispatch uh, in case of a mechanical energy storage, there is a flywheel, then pump hydro energy storage system, compressed air energy storage system, which was available at lot particularly. So when we say the flywheel energy system, which will store electricity in the form of rotational kinetic energy. So this is what we need to tell sort of cultivate among the students. What we need to add this from the first year instead of basic electrical engineer. First we need okay. So then or okay then add the things. Okay, so this what I'm thinking on from my side, but I don't know how much it will be effective in the society. And that student is presently is very means that they are grasping the things very fastly but they are busy on the mobile phone and this all the chit chats and all the social platforms. So therefore, they are not focusing on the proper study. So therefore, what we need to say that case. So then another is the compressed air, which was one of the electricity which power compresses to store the energy in the form of compressed energy in the vessel, while the energy can release into the gas turbine to save the use of natural gas, particularly gas. So this is one of the electrochemical energy storage system. So where energy is transferred between the electrical and the chemical energy stored uh, in case of active chemical components through a reversible. So these are the we can say the battery is a good example of that. And there are primary cells and secondary cells are there. So when I'm going to say the reversible action means it's a secondary cell. So you are going to get a good paper on that which was there in a published. So I given in this in a reference. Another is mm, flow battery energy storage systems, which was redox flow battery. Redox flow is battery basically used in Japan. Is one of the most popular type of flow batteries. Large capacity with a single unit, and it have long life cycle life. So this we can also take in a particularly consideration where we can say that is a these batteries we can make in electricity generation. Another, yeah, this was a no, popular in case of energy storage system. Till date, we used to use the, and then we have the uh, UPS and particularly um, when energy storage system large unit, most probably we used to see that lead acid batteries for the energy storage because it have a good ampere hour capacity for the storage which can we can do you know and in recent trend is coming is what people are thinking is on the nickel and lithium. So this also a good opportunities for energy storage in case of chemical energy storage. Lithium-ion batteries basically have a highest energy density among the all electrochemical energy storage systems, which have a good long life cycles. And because of its high cost and the fast aging, resulting deep charge and discharge cycles. What, although we are thinking from the 2018, see this was continuously decreases up to 2018, the particular cost of this lithium and maybe, but how to particularly recycle it. So that was again a big issue in case of lithium-ion batteries. Now this sodium-ion batteries, which was we can they are distinguished from the other batteries due to their solid electrolyte. So these now are going to come into the market where in case of because of the high power energy and the energy density, which have also good long life. So this is what we are discussing about the chemical energy storage system. Next one is a electrical energy storage system, where we can see the ultra capacitors have a high power density with 95% efficiency and long lifetime, with suffer from the high self-discharge rate and high cost. Even a superconducting magnetic, that SMESS, that is a superconducting magnetic energy storage system. Here also Tesla is working on this particularly concept. Where energy storage system through superconductor. In a thermal energy storage system, most probably heat will be converted into the electricity generation. So depending on the operating temperature, because again the thermal issue is the temperature is going to play a vital role here. So that need to be somewhere we need to consider in case of a global. Uh, so in case of if you're going to compare, which was energy storage technology, then uh, this technology it says that of what unit of energy basically, okay, that cost based on the till date use is a lithium ion and flow batteries are currently the most popular electrochemical choices for the energy says in case of the electricity storage system. Most of these things I have covered in energy storage system. Last is optimal, what we can say the battery power dispatch for a cognition relief. In this case, that unit commitment and economic dispatch is important. So in that case, some variables are need to be considered, and we need to form the equations in the form of particularly commitment of that particularly parameters, start status, and then power generator cost curve, then total output power, then power curtailing to the Kate solar plant, and voltage angle at the bus. So this is about the energy storage system. So any particularly faculty or have any questions? Uh, Please, the forum is open. I think that few of them are there. So yeah. Yes, yes, yes. Okay. So this is from my side. Thank you for listening it patiently. Most of the MATLAB simulation we covered before the link get damaged. Okay, so if required, this will be also available on the MATLAB simulation platform of the own website of MATLAB. Okay, so that you can, but what you need to do is change the parameters as per your design specification. So this is from my side. Thank you, all the participants listening in present. So thank you, Kosai sir. So can yeah. Thank you. Yeah, thank you, sir. Thank you, participants, and thank you, management, for thank you, Department of Electrical Engineering, Papujiro Saleke, Institute of Engineering and Technology, Kolhapur. Thank you.